Hello students, welcome back to our channel Diksha Karnataka. So all of you have completed your KCET Chemistry 2024 exam. So in this video, we will be discussing the detailed solutions of all the 60 questions. So the set I'll be discussing is your set number B4, okay. So you can just tally this one with your other question papers. The question paper numbers will be different. So you can just check that and can calculate your scores, okay. So now if you see, if you want the PDF of this question paper, it is available in the WhatsApp channel and the link of the WhatsApp channel will be there in our description section, okay. So let us go with the first question. So this is, I'll repeat again, these questions are from your set B4, okay, clear. So now let us see here. 0.48 gram of an organic compound on complete combustion produce 0.22 gram of percentage of carbon in the given organic compound is, okay. So now if you see here, any combustion, whenever you do any combustion, carbon dioxide is a byproduct, right? So I can say if 44 gram of CO2 is produced, that is the molar mass of carbon, right? Molar mass of carbon dioxide. So in every 44 gram of carbon dioxide produced, what is the amount of carbon? 12 gram is carbon. So in 1 gram of CO2, it will be 12 by 44 gram of carbon. Now in the question, how much gram of carbon dioxide is produced? 0.22. So if 0.22 gram of carbon is there, carbon dioxide is there, then it will be 12.44 into 0.22, right? So I can write it like this, 22 by 100, so 0.06, right? So the carbon that was there in this organic compound is 0.06 gram. Now if it is asked to calculate the percentage of carbon, right? So percentage of carbon is the mass of the carbon divided by the total mass of the organic compound into 100. So percentage of carbon will be equal to 0.06 divided by 0.48 into 100, okay. So now if you solve this, the correct answer for this question will be 12.5. That is your option number C, 12.5 gram, okay. Now let us see the next question. In the given sequence of reaction, identify P, Q, R and S respectively. So here we have Br, okay. So now if you see one double bond is there, two bromines are getting added. So that is your Br2, addition of Br2. So HBr will not be there because HBr will add one H and one Br, right? So in Br2 there will be two bromine added. So that is why option A and option D can be the answer. Now you see there is one elimination of HBr. For elimination of HBr, we use alcoholic KOH. So we have alcoholic KOH here, we have alcoholic KOH here also. Now for removing another pair of HBr, that is this H and this Br. To remove this another pair of HBr, we need to use NaNH2. So that is why this one is wrong and this one is correct, okay. So the correct answer for this question will be option number D. So after getting this one, this is your cyclic polymerization in presence of red hot. So here we will get actually, we will form a triple bond here, right? So ethyne will form, then for the ethyne we have to use your triple cyclic polymerization, for that is red hot iron tube. So we will get benzene, okay. Next question, the first chlorinated organic insecticide prepared is your DDT, okay. The correct answer for this question is option number D. So this has come from your the importance or the important compounds of haloalkanes and haloarenes. So from there this topic is there. Next question number 4 is from the solid state, okay, solid chapters. Which of the following crystals has the unit cell such that A equal to B is not equal to C, and we have alpha equal to beta equal to 90 degree and gamma equal to 120 degree. So this is actually from the solid state, the Bravais lattices are there. In that we have one hexagonal, for that the correct example is graphite, okay. Correct answer for this question is option number B. Now coming to next question, MnO exhibits. So here MnO has, if you see, it has antiferromagnetism because of the magnetic moments. The magnetic moments of this one cancel each other, okay. They are in opposite direction and in equal in number. So because they cancel each other, the correct answer for this question will be antiferromagnetism, okay. This is also from your chapter solids, where they have given about the magnetic properties. Next question number 6, this is also from your solid state. Okay, so the number of atoms in 4.5 gram of a face centered cubic crystal with edge length of 300 picometer, density is given, Na is given. Okay, so now I'll tell you how to solve this question exactly. See, first of all, we have a formula for solid. Density is equal to Z into M, where Z is the number of atoms, M is the mass, divided by Na into A cube, right? Now what we can do is A cube is your side length, cube of the side length, Na is Avogadro number, Z is the number of atoms present in a unit cell, M is the molar mass. Now we have to calculate the number of atoms, right? Number of atoms formula we know, number of atoms will be equal to, see here, number of moles into Avogadro number. Number of moles is what? Given mass. Number of moles formula is given mass by molar mass. Okay, given mass by molar mass into Avogadro number. Okay, into Avogadro number. Now here what we can do, the given mass is 4.5 gram. Instead of molar mass, we can just, this is also molar mass here, this is also molar mass here, right? So from this one, this molar mass, what we can do, we can substitute the value of this molar mass here, right? So what we will get here, molar mass is equal to density Na A cube divided by Z. Okay, I'll write it as Na capital U. So density Na A cube by Z. So this value substitute here, we will get as given mass, okay, divided by, in place of molar mass, we can substitute density into Na into A cube into Z, then this Na is also there. Okay, now this Na will get cancelled. So we have this one, given mass divided by into Z divided by rho into A cube. So now you can substitute all the values. Given mass for this substance is 4.5 gram. Okay, and Z value for FCC, the Z value is 4. So that is why here 4. Then density is your 10 gram per centimeter cube. Okay, and then we have the side. So side we have to do little what we say unit conversion. 300 picometer is there, so I can write 300 into 10 to the power of minus 12 meter. Okay, but you see density is in centimeter, so again we'll convert it into centimeter. So I can write 300 into 10 to the power of minus 10 centimeter, right? So I can write this one as 3 into 10 to the power of minus 8 centimeter. So we can substitute here 3 into 10 to the power of minus 8 centimeter cube. Okay, so now if you solve this one, we are having, we will get 6.6 into 10 to the power of 22. Okay, so the correct answer for this question will be option number D, that is 6.6 into 10 to the power of 22. Okay, so this question was from the deleted portion, but this formula may be known because it is one of the important formula from the solid chapter. Next is very important question, easy question from solutions chapter. Okay, so vapor pressure of a solution containing 18 gram of glucose and 178.2 gram of water at 100 degrees Celsius is. Vapor pressure of pure water is given to you 760 torr. So whenever we add a solute, what happens to the vapor pressure? The vapor pressure decreases. So you have to calculate the decreased vapor pressure. So we have this formula, relative lowering of vapor pressure is equal to XB, right? So we will calculate XB first. So for that we need NB and NA. So what is the number of moles of glucose? Glucose number of moles will be 18 by 180, that is 1 by 10, and number of moles of water will be your 178.2 by 18. We have here 178.2 divided by 18. Okay, so now we can substitute these two, it is 0.1. Okay, so now we can substitute this value here. P naught value is 760. Okay, and P value is this one, this is again 760, and here we can substitute the number of moles of glucose, that is 0.1 divided by 0.1 plus 178.2 divided by 18. Okay, so now if we solve this value, the p value we'll be getting will be 752.4. Okay, but this question easily you could have guessed the answer also without doing this much calculation, because you see the original pressure is 760, the decrease will be there, some extent decrease will be there, so it will not decrease like 76. From 760 to 76 is a huge gap, right? And then we have 7.6, this is also wrong, this will also be wrong. Now this one is more than the vapor pressure, so the vapor pressure should not increase, it will always reduce, so this option also could have been eliminated. So the most probable answer should be option number B. Okay, so the correct answer for this question is option number B. Now coming to the next question, again from solutions chapter. A mixture of phenol and aniline shows negative deviation from Raoult's law. This is due to the formation of. So negative deviation means the intermolecular forces will increase, and if you see we have aniline here, aniline structure is this one, and we have phenol here, that is OH, right? So there can be a possibility of hydrogen bonding here, so that is due to intermolecular hydrogen bond. So correct answer for this question is option number C. Next, which one of the following pairs will show positive deviation from Raoult's law? So positive deviation means the force of interaction will decrease, right? So now if you see benzene and methanol, okay, methanol earlier will have that is intermolecular hydrogen bonding. When you add benzene to it, the intermolecular hydrogen bonding of methanol will decrease, so it will show positive deviation. So the correct answer for this question is from option number B. Okay, so we can see 3 questions were there from the solutions chapter. Okay, very direct and easy questions. Now coming to electrochemistry, so question number 10 belongs to your electrochemistry chapter. How many coulombs are required to oxidize 0.1 mole of water to oxygen? So if you see in water, what is the state of oxygen? O2 minus will give you half O2 plus 2 electrons, right? I can write the reaction like this. So I can say now for 1 mole, so this O2 minus has come from 1 mole of water, right? So for 1 mole of O2 minus, how many electrons are required? 2 moles of electrons, or 2 Faraday is required. Now if it is 0.1 mole of water, okay, so I will get 0.2 Faraday, right? Now 0.2 Faraday is how many coulombs? So we know 1 Faraday is equal to 96500 coulomb. So 0.2 Faraday will be equal to 19300 coulombs. Now this can be written as 1.93 into 10 to the power of 4. Okay, so the correct answer for this question will be option number B. Okay, that is 1.93 into 10 to the power of 4. Now let us see the next question. A current of 3 ampere is passed through a molten calcium salt of 1 hour 47 minutes and 13 seconds. So this question is also from electrochemistry, and the Faraday's law, very simple question. The mass of calcium deposited is, so we have to use Faraday's first law, that is M is equal to Z into I into T. Okay, so here the only thing that you have to calculate correctly is your time. Okay, so if you see here we have 1 hour is 3600 seconds, and then 47 minutes, 47 into 60, right? So that we will get 2820 seconds, then plus we have this 13 seconds, right? So total if you add, we have 6433 seconds. So that is the time here. Z value is your, Z how to calculate? Z is molar mass divided by N into 96500. Now for calcium, the N value will be 2, right? Because 2 plus means 2 electrons will be required. So we can have here molar mass is 40, 2 into 96500 into current is your 3 ampere and time is 6433 seconds. So if you solve this one, the correct value will be around 4 grams. Okay? The correct answer for this question will be option number D, that is 4 gram. Easy question, little bit calculation is there. Okay, next question is also from electrochemistry. So the value of A in the equation, this one is same for the pair. So one similar question we have discussed during the mock test also. So A value will be same. Okay, in which case the A value will be same if the charges of the electrolyte are same. Charges of electrolytes are same. Okay. Now for example, if you see NaCl, Na is +1, Cl is -1. So this type of electrolyte is 1,1 electrolyte. Now if you see calcium to CaCl2, calcium charge is +2, chlorine charge is -1. So this is 2,1 type electrolyte. Again this one, CaCl2 is 2,1 type, MgSO4 is 2,2 type. NaCl is 1,1 type, KBr is also 1,1 type. So if both the electrolytes are of same type, their A value will be same. So the correct answer for this question will be option number C. Okay, NaCl and KBr. Now let us see the next question, 13. Okay, so here was a reaction, equilibrium reaction was given. For the reaction A to B, this was a question from kinetics. Okay, so we got 3 questions from solutions, 3 questions from electrochemistry, and the next is from kinetics. So for the reaction A to B, activation energy is 50 kilojoule per mole, and the delta H value was 20 kilojoule per mole. Okay, this is delta H value. And then when a catalyst is added, EA decreases by 10 kilojoule per mole. What is the EA for the backward reaction in the presence of catalyst? So if you could have done the diagram correctly, this question was very easy to solve. So if you see here, we have this one. Okay, reaction to product. Okay, this is reactant and this is product. Now what happens, the activation energy is the energy between the reactant and the threshold energy. So what is this value? So this value which is there is your 50 kilojoule per mole. Okay, this value is 50 kilojoule per mole. Now what happens, when a catalyst is added and the delta H value is also given, delta H is -20, that means energy of the product is less than the energy of the reactant. So you can see here, energy of the product is less than, so this value, delta H is nothing but the difference between the enthalpy of products minus reactants. So this value was 20 kilojoule per mole. Okay. Now when the catalyst was added, the activation energy decreased by 10 kilojoule per mole. So what happens now, we can do here this one. Okay, this is the graph after adding your catalyst. So the energy has decreased by 10 kilojoule per mole. So this value is 10 kilojoule per mole, right? So if total was 50, this is 10, then this one will be 40, right? So now the question is asked, what is the activation energy for the backward reaction? So which is the activation energy for the backward reaction? This is the activation energy for the backward reaction, where this is 40 and this is 20. So total will be 60 kilojoule per mole. Okay. So the correct answer for this question is option number A, that is 60 kilojoule per mole. So this was an easy question. Little you should know the diagram of catalyst properly. Now let us see the next question. For the reaction, so this question is again from chemical kinetics. For the reaction PCl5 gives PCl3 plus Cl2, the rate and the rate constant values are given. Okay, and then you have to calculate the concentration. So this was very easy question. We know rate law formula, R is equal to K into concentration, right? So you can see that the rate constant value or the rate constant unit was second inverse. So from that you could have guessed it is a first order reaction. Now just substitute the values here. Rate value is your 1.02 into 10 to the power of -4, and K value is 3.4 into 10 to the power of -5. And then we have concentration of A. So if we find the concentration of A, it will be 1.02 into 10 to the power of -4 divided by 3.4 into 10 to the power of -5. Okay. So now if you solve this, this value we will be getting is 3 into 3 will get 3 mole liter inverse. Okay. So the correct answer for this question will be option number B. This was very easy question. Okay. Next question is also from chemical kinetics. So you can see we have got 3 questions from all the important topics here. First is Arrhenius equation. Which of the equations can be written in the form of Arrhenius equation? So if you know, Arrhenius equation is K is equal to A into e to the power of minus EA by RT, right? So now if you take ln on both sides, we'll get ln k is equal to ln A minus EA by RT. Now if I take log on both sides, we will get log K is equal to log A minus EA by 2.303 RT, right? So these three equations were given. Here this equation was there with positive value of EA by RT. So that equation will not be there at any condition. So the correct answer for this question will be option number D. So all the three questions from kinetics were very easy. You could have easily scored marks in these questions. Now coming to next question. Again, okay, this question is from your like surface chemistry chapter, which was a deleted topic. So colligative properties, values of colligative properties of colloidal solution are of small order compared to the values of true solution. So this is a correct statement. Tyndall effect is observed only when the diameter of the dispersed particles is not much smaller than the wavelength of light. That is correct, because if the size is similar, then only the particles will be visible. Okay. The color of the colloidal solution depends on the wavelength of light scattered by the dispersed particles. Okay. So the wavelength of light that dispersed, that color will be visible in the solution. And the last one, Brownian movement is due to the balanced bombardment of molecules of dispersion medium on colloidal particles. So this part is wrong. It is due to the random bombardment. Okay, there is no pattern in that. So the correct answer for this question is option number D, which is the incorrect statement. Now coming to next question. This question is also from surface chemistry, which was the deleted portion. Coagulation power, you should remember. Coagulation power, okay, is directly proportional to the charge. Okay. Higher is the charge, higher will be the coagulating power. So if we have a positively charged swole, okay, so to coagulate it, we will require more negative charge. So you can see here in option number D, 4 minus, then 3 minus, then 2 minus, and then minus 1. So the correct answer for this question is option number D. Now next question. Again, this question is from surface chemistry. So we have got three questions from surface chemistry. So gold is not a, so macromolecular colloid is the correct answer here. Okay, so because it is not like made up of many particles, it is made up of like it's not a very big colloidal form. It doesn't contain more number of particles. So it is a macromolecular colloid. It is not a macromolecular colloid. Okay, here it is lyophobic, it is multimolecular, and it is also negatively charged. So the correct answer for this question will be option number A. Okay, that is macromolecular colloid. Now let us see the next question. Okay, so this question is from extraction of metals, or that is your metallurgy. So the incorrect statement about Hall-Herold's process. Okay, so what are the incorrect statements? So this is a process used in the extraction of aluminium. Okay, extraction of aluminium. So carbon anode is oxidized to CO and CO2. This is correct statement. NaAlF6 helps to decrease the melting point of the electrolyte. This statement was also correct. CaF2 helps to increase the conductivity of the electrolyte. This is also correct. So these are the different things that were used in this process and what are their functions. Now oxidation state of oxygen changes in the overall cell reaction. This is incorrect. Oxygen state remains the same throughout the process. Carbon gets oxidized, so its oxidation number changes. So the incorrect statement is option number D. So the correct answer for this question will be option number D. Next. Again, this chapter is from metallurgy. This question is also from metallurgy. We have select the correct statement. So roasting involves heating the ore in the absence of air. This is incorrect because it happens in presence of air. Next, calcination involves the heating of the ore above its melting point. So this is also wrong. It is below the melting point. And then smelting involves heating the ore with suitable reducing agent and flux below its melting point. This statement is also incorrect. Okay. Now calcination of calcium carbonate is endothermic. This is the correct statement. So the correct answer for this question is option number D. So next question, NO2 gas is, okay. So if you add NO2 to water, we will get nitrous acid, which is an acid. So NO2 is acidic in nature. Okay, so that is why it will be acidic. It's acidic, it is not neutral. We can eliminate these two options. Now if you know the color, NO2 is a brown fume gas. So the correct answer for this question will be option number C. Now let us see the next question again. So this question was from your we can say P block. Okay. Next one, identify the incorrect statements from the following. So this question is also from your P block, that is group number 16. So oxides of nitrogen in the atmosphere can cause depletion of ozone layer. So this statement is correct. Then ozone absorbs the intense UV radiation of the sun. See this question, although it was from your P block, but the statements that are given are very general science things, right? We already know what is ozone depletion and how ozone is created, and also these statements were very easy. So you should have done it correct here. Depletion of ozone layer is because of chlorofluoroalkanes. So this is also there. And then ozone absorbs in infrared radiation. So you know this is incorrect because it absorbs UV radiation. So the correct answer for this question will be option number D. Okay. So next question is again from, okay, now we have come to, yes, again this is from group 17. P block, this was from group 16. This one was from group 15. Okay, the correct decreasing order of boiling point of hydrogen halides, if you see, as the mass increases, the van der Waals forces increases and the boiling point should increase. So the expected order for this one should be HI, HBr, HCl and HF, right? But due to the strong hydrogen bonding in HF, the intermolecular hydrogen bonding increases, the bond strength increases, so the boiling point of HF increases. So the order becomes like this. Okay. So the correct answer for this question is your option number B, that is HF, HI, HBr and then HCl. Okay. Next question. So the synthetically produced radioactive noble gas by the collision of CF with Ca. Okay. So this was answer for this question. This leads to the production of synthetic noble gas, that is oganation. Okay. The correct answer for this question is option number C. Next. So now we have come to your D and F block part. The transition element present with lanthanide metal in mic metal is. So this is one of the important alloy. So here the element from the transition element is Fe. So the correct answer for this question is option number B. Next is again from D and F block. We have Zn2 plus. We know Zn2 plus has the electronic configuration of Zn2 plus is D10. It has no unpaired electron, so it will be colorless. So your first one will be 2. This is compound 1, 2 and 3, right? So 1 will be 2, so we can eliminate option A and D. Now if you see Cu2 plus electronic configuration is 3d9. Okay, so 3d9 configuration, if you see, we have like this 1, 2, 3, 4, 5, 7, 8 and 9. Only one unpaired electron is there, so magnetic moment will be root over of 1 into 1 plus 2. That is root 3. So it is 1.73. So the correct answer, the correct one for 2 is option number 3. Okay. So the correct answer for this question will be option number B. Now Ni2 plus is D8 configuration. Now let's see the next question. Which of the following statements led to lanthanoids is incorrect? So this is again from D and F block. Okay, so lanthanides are silvery white soft metals. This is correct. This was very easy question. Samarium shows +2 oxidation state. This is also correct. Ce+4 is widely used as oxidizing agent. This is also correct statement. Color of lanthanides in the solution is due to DD transition. This is incorrect. Okay, this is due to FF transition. So the correct answer for this question is option number D. Okay. Next, we have from coordination chemistry. Okay. So on treating 100 ml of 0.1 m aqueous solution of complex CrCl3.6H2O with AgNO3. So we have this complex .6H2O plus you treated it with AgNO3. Okay. We got 2.86 gram of AgCl. Right. Now the question was, what is the complex structure? Okay. So you should be able to know like how much this is the number of moles of complex and this is the number of moles of AgCl obtained. So now let us calculate both. So number of moles of complex we have been given with the molarity and with the volume. So if we multiply molarity and volume, we will get number of moles. So 100 into 0.1, we will get 10 millimoles. Okay, this is the number of moles of complex. Now what is the number of moles of AgCl? Number of moles of AgCl. So if you see, the given mass is 2.86, okay, and molar mass of AgCl is around 143. Okay, so now if you see, it is around 2, so I can write 0.02, right? 2 3s are 6, 2 4s are 8, and 2 1s are 2, so 0.02. Now how to calculate? So we can calculate this one as n value, like how many chlorines will be there outside. So just divide these two ratio, that is 0.02 divided by 10 into 10 to the power of minus 3. So now if you solve this, we will get 2, right? So that means 2 chlorine should be outside the complex. Now if you see the structure here there is no chlorine, here there is 1 chlorine, and here there is 2 chlorine outside the complex. So the correct answer for this question is option number C. Okay, so this one is like you have this question from your Werner's theory. You might not have known the process, but if you like this, just imagine and do it. It was not a very difficult question. It was somewhat a moderate level question from coordination chemistry. Now coming to next question, again the question is from coordination chemistry, very easy question about isomers, very important topic. Here if we put it in water, we will get this complex and Br minus, and if we put this one in water, we'll get this complex and SO4 2 minus, right? So now if you see, the ions produced are different, so it is a ionization isomer. Correct answer for this question is option number D. Now next question, again from coordination chemistry, we got 3 questions from all the major topics. COF6 3 minus iron. Okay, so this complex has octahedral geometry. It is correct because 6 is the coordination number. Next, coordination number of cobalt is +3 and oxidation number is +6. This is incorrect. Coordination number is 6, oxidation number is +3. Now the complex is sp3d2 hybridized. Yes, because it is weak field ligand. Then it is a high spin complex. This is also correct. So the correct statements are 1, 3 and 4. So the correct answer for this question is option number C, 1, 3 and 4. Now next question. Next question is from haloalkenes, okay, and haloarenes. The haloalkane undergoes SN1 and SN2 reaction depending on the solvent used in the reaction. So if you know this one, for SN1 we need protic solvent, okay, and for SN2 we need aprotic solvent, right? So the correct answer for this question is option number A, okay. And then low temperature has nothing much to do, and then the type of halogen atom, it is not there. Stability of haloalkane, okay. So actually if we see the stability of the carbocations, okay, the carbocation formed in the compound, that actually depends the reaction or the rate of reaction, whether it will be SN1 or SN2. So D, in that case D, if you study about stability of carbocation, then D can also be a probable answer for this question. Okay, so let us see what is the answer key releasing. So for now the answer which we recommend is option number A. Okay, next 32, 2-methyl propane can be prepared by Wood's reaction. The haloalkanes taken with metallic sodium and dry ether is. So 2-methyl propane we have, right? So we should remember that whatever haloalkanes you take, that should be one of them should be at least primary. So we can take like this, one is CX and another is this one, right, or CX. So this XX will go and this part will join here. So one is your chloromethane and another is your 2-chloropropane. So the correct answer for this question is option number A. This one again an easy question. Next, again, so we have got this question is from haloalkanes, this question is also from haloalkanes, this question is also from haloalkanes. Now whenever we have fluoroalkane, okay, there is a metallic fluoride should be used. So we can see HF is not there, AgF and Hg2F2 should be there. Now Y is your elimination reaction, for that we need alcoholic KOH, this is also correct. And then this one C4H10, you see the number of carbons has doubled, right? In that is the case of Woods reaction. For Woods reaction, we need sodium in dry ether. So the correct answer for this question is option number C. Next one. Okay, this is little difficult, like little easy, good question from alcohols chapter. Okay, so 8.8 gram of monohydric alcohol is added to ethyl magnesium iodide in ether, liberates this much gram of ethane at STP. So what does this one is saying? See, whenever you react any ROH plus R dash MgX, okay, it will give you R dash H. Okay, this is your alkane produced, right? So now what happens? One alcohol was there, it was reacted with this one ethyl magnesium. So here R dash is ethyl, right? Ethyl magnesium iodide in ether liberates. So R dash H will be what? Ethane. This ethane is 2240 centimeter cube or 2240 ml, right? Now if you convert it into STP, what is the number of moles of ethane produced? Okay, number of moles of ethane produced will be given volume by molar volume. So what is the given volume here? 2240 and molar volume is 22,400. So we can have 0.1 mole. Okay, so now you see, so 1 mole of this one reacts with 1 mole of this one. Now if, and to give you 1 mole of alkane, okay, so just see here, 1 mole of alcohol reacts with 1 mole of Grignard reagent to give 1 mole of alkane. Now if the number of moles of alkane produces 0.1 mole, then the number of moles of alcohol should also be 0.1 mole, right? This part is clear. Once again, see here, 1 mole of alcohol reacts with 1 mole of Grignard reagent to give you 1 mole of alkane. If the moles of alkane produced is 0.1 mole, then the mole of alcohol must be 0.1 mole, right? Now we have been given with this, mass of this one was given, so we can calculate the molar mass of this one. So we know number of moles is equal to given mass by molar mass, right? So I can write here molar mass of this compound will be 8.8, that is given mass, divided by number of moles is 0.1, that is 88. Okay, so now we know the compound molar mass must be 88 gram. Now let us see the next part of the question. This monohydric alcohol, when oxidized using PCC, forms a carbonyl compound that answers silver mirror test. So that means it must be one aldehyde is produced, and aldehydes can be produced from primary alcohol. So the compound or the monohydric alcohol must be a primary alcohol, right? Now if you see the options, this is a secondary alcohol, this is a secondary alcohol, right? So we can eliminate these two options. Now we should see from these two options, it should be 88 gram, the molar mass, that will be the answer. Now if you see this structure, propane 1-OL and we have 2,2-dimethyl. Okay, now you can just see, calculate its mass. Okay, so 1, 2, 3, 4, 5 carbon are there, so 12 5 is 60 plus hydrogen we have 1, 3, 3, 3, 9, then we have again here 12, okay, and then we have 1 oxygen, that is 16. So if you add, we have 88 gram, right? So the molar mass of this compound is correct. So the correct answer for this question will be option number B. Now next question. This question is also from your alcohols chapter. When a tertiary alcohol A, C4H10O, reacts with 20% of H3PO4 at 358 Kelvin, it gives a compound B, that is C4H8. As a major product, the IPAC name of the compound is. So if you know tertiary alcohol with 4 carbons, then that structure is like this, right? This is the structure given. Now 20% of H3PO4 at 358 Kelvin. So what will do? H3PO4 will do dehydration, right? So dehydration means this one will go. So we will get the compound CH3C, CH3, C double bond H2, right? So what will be the name of this compound? 2-methyl propene. Okay, so the correct answer for this question is option number D. This one was easy question. Now again we have come PCC. PCC is all of you might be knowing, chromium trioxide with pyridine plus HCl. So correct answer for this question is option number D. Next we have come propanol and propanol. This is one of the most easiest question. These are two functional groups. So the correct answer for this question is functional isomers. Next, sodium ethanoate on heating with soda lime gives X. So sodium ethanoate, if you know the structure, okay, this is sodium ethanoate. When you do heat with soda lime, it causes decarboxylation. So this part will go and we will get methane as one of the product, right? So first option should be methane, so we can eliminate these two options. Now the aqueous solution of this one gives you Y, okay? So if it occurs aqueous solution, electrolysis if you do, okay, so in electrolysis we produce ethane, okay, so one of the byproduct is ethane here. So the correct answer for this question is methane and ethane, that is methane and ethane, that is your option number A. So here what happens, this breaks like this, we get CH3 dot, another CH3 dot is produced and they then combine to give you CH3. Okay. So this is from your Cole's electrolysis. If you can see that mechanism, this is there. Next question. Butane reacts with dilute H2SO4 in presence of Hg2 plus. The ions at 333 Kelvin gives you what? So this one is also easy question. If you take butane and if you add this one Hg2 plus in presence of H2SO4, it actually adds water following Markovnikov's rule. So we will have this one, right? Now what happens, there is tautomerization and we will get this compound. So the correct answer for this question is option number A. Okay, next we have biologically active adrenaline and so we have come to your biomolecules chapter. Contains this is your amines chapter, importance of amines. Contains your which amino group? That contains your secondary amino group. Correct answer is option number B. Okay, next, this one is a easy question, very important reaction, coupling reaction we have here. Aniline is there, NH2. When you treat it with NaNO2 dilute HCl, it forms diazonium salt. We will get this one. Okay. Now if you take it with phenol, so there is a coupling reaction here. So we can get this one, N2 plus Cl minus, and it is reacting with phenol, right? So here reaction takes place and we get this compound. Okay, so this is para-hydroxy-azobenzene. Okay, correct answer for this question is option number C. This one was easy question. You also have two coupling reactions from this chapter, so it is very similar to that. I think most of you have done correct in this question. Next one, female sex hormone which is responsible for the development of secondary female characteristics and participates in the control of menstrual cycle. So this is your estradiol. Okay, correct answer is option number B. Next, the type of linkage. So we have come to biomolecules chapters now. So the type of linkage present between nucleotides, that is very common, phosphodiester linkage. Correct answer is option number B. Next, alpha D glucose and beta D glucose are. So you know, if there is a difference in the configuration at any one carbon and that carbon should be carbon number 1, then we call it anomers. So in glucose it takes place in the carbon number 1. So the correct answer for this question is option number D. Okay. Next question. So this question is from your polymers chapter, okay, which was a deleted portion. We got around 2 to 3 questions from this chapter also. So which of the following sets of polymers are used as fibers? So the correct answer is sterylene and orlone. So that is 3 and 4. Correct answer for this question will be option number C. Next, again the biodegradable polymer obtained by the polymerization of glycine and aminocaproic acid is nylon 2, nylon 6. Correct answer for this question is option number C. This question is also from your polymers chapter. Next, so this question has none of the answer correctly matches to this question. So we have to leave this question and wait for the KEA what is the answer key release. So for now this question, none of the answers is correct for this one. Okay. Next one. So again this question has come from your thing, the compound deleted portion. Cationic detergent, that is your cetyl trimethyl ammonium bromide. Correct answer is option number A. So these are very theoretical questions, nothing to be explained. So if you would have studied something, it could have been there, but fine. Let us see next question. For which one of the following is the composition uniform throughout? So this is very easy question from solutions chapter, I think. Uniform throughout, sand and water is not there, grain, this is not there, this is also not there, dilute aqueous solution of sugar, this is your uniform composition. Correct answer is option number D. Next, coming to structure of atom, the energy associated with the first orbit of He+. So we know energy of any nth orbit is equal to minus 2.18 into 10 to the power of minus 18 Z square by N square, right? So now if I substitute here, Z value is how much? Hydrogen, helium, that is 2. So 2 square is 4. First orbit is 1. So if I solve this, I'll get minus 8.72 into 10 to the power of minus 18. Correct answer for this question will be option number B. This is question from your structure of atom. Okay, easy question, direct formula based question. So I hope everyone should have done correct in this question. Next. A metalloid is, so this is from again your classification of elements and periodicity of properties. Element is your SB. Correct answer for this question is option number B. Next, a pair of isoelectric, so we have come to now chemical bonding. A pair of isoelectric species with bond order of 1. So this is very simple, you know, N2 structure is like this, bond order is 3, so this cannot be answered. CO structure is like this, right? So this cannot also be not there. F2 and O2 2 minus, bond order is 1 and both of them are having 18 electrons, right? So the correct answer for this question is option number C. Next, so this question was also from deleted portion, that is states of matter. Okay, so this is question is from real gas. So these equations are correct. P ideal is equal to P real plus N square by V square. V real is equal to V ideal minus NB. This is also real gas equation. Z is equal to actually V real by V ideal. This statement is incorrect. So correct answer for this question is option number A. Next one. Okay, so we have come to now thermodynamics. From the diagram, delta H of the reaction we have to find out. So you can see A to 2B. Okay, delta H given is, we have to calculate from for the question was to calculate from A to C, delta H from A to C. Okay, so now if you see, the question was to calculate the delta H of the reaction from C to A. Okay, if you remember, it is from C to A. Now if you see A to 2B is delta H is 10 kilojoule. Now delta H2 is 2B to C, right? So that is your 25 kilojoule or 25 joules, both are joules here. Now if I add these two reaction, I'll get A to C, that is 35 joules, right? But the question is asked from C to A. So whenever the reaction is reversed, the delta H values become negative. So if A to C is 35, then C to A is equal to minus 35. Okay, so the correct answer for this question will be option number C. Okay, next one. So this is again a little bit from ionic or equilibrium part, where KSP product is there, the concept is there. In the analysis of group 3 basic radicals of salts, the purpose of adding NH4, okay, this was to adding NH4Cl to it is, okay. So when we add this one, what happens? It suppresses the dissociation of NH4OH. Okay, correct answer for this question is option number C. Now let us see the question number 56. This question is from your solubility product. Okay, this is very easy question. If you see calcium oxalate, how will it dissociate? It will dissociate as Ca2 plus C2O4 2 minus, right? So now if this solubility is S, this solubility is S, so what I can say, KSP is equal to S square. right? Now KSP value is given, actually this was 10 to the power of minus 9. So 4 into 10 to the power of minus 9 is equal to S square. So now if you see, many of you yesterday when I was discussing the answer key, many have written 4 root over as 2. But you have to check that this is 10 to the power of minus 9. So you should write it in such a way that you will get it around somewhere. This one should be made in such a way that its square root can be taken. So I can write it as 40 into 10 to the power of minus 10 is equal to S square. So now if I take root over now, so this will be around somewhere around 6.3 into 10 to the power of minus 5. The correct answer for this question will be option number A. Okay. So now let us see the next question. In the reaction between moist SO2 and acidified permanganate solution. So this is very easy question. Acidified permanganate solution is KMNO4, right? Here the oxidation state of manganese is +7. It cannot further undergo oxidation. It will undergo only reduction. So MnO4 minus will definitely be reduced. So we can eliminate these two options. Okay. Now if you see SO2, right? SO2 should be oxidized. Okay. What's the oxidation state of SO2 is here? +4. Now if you see here option number A, it is going to SO4 2 minus, so that is +6. Now if you see option number C, SO2, here it is +4 and here it is going to SO3 2 minus, so that is x minus 6 is equal to -4 minus 2. So again it is +4. So here you see S is not undergoing any oxidation in presence of manganese. So that is why this statement is also incorrect. This statement is correct. That is option number A. Okay, where SO2 is undergoing oxidation from +4 to +6. Manganese is going from +7 to +2. Okay. Next, which of the following properties is generally not applicable to ionic hydrides? So this is again simple question. Ionic hydrides are having very strong bond between them, so they are not volatile. So the correct answer for this question is option number D. Next, which of the following nitrate will decompose to give you NO2 on heating? So the only nitrate which gives NO2 on heating is lithium nitrate, and all others will produce oxygen. Okay, correct answer is option number D. So last question, which of the following hydrates cannot be hydrolyzed? So that is your CCl4. This is due to absence of d orbitals. Okay, so we know all the elements of the first period are having some anomalous properties. One of this is this one, that is absence of d orbital. Okay, so these were the 60 questions that were asked in your KCET 2024 chemistry of B4 set. Okay, so we have solved all the questions in detail. If you have any doubt in any question, you can write in the comment section. We'll discuss it in the next video. So there were some questions from the deleted portions, but like those questions were which were there in the syllabus, they were very easy. So deleted portion questions are there for everyone, right? If you haven't solved, then other people also might not have solved it, so you need not worry. If you have found this video helpful, please like, share and subscribe our channel. Thank you.